Problem 2371. Balance the combustion reaction of the hydrocarbon dodecane. Dodecane plus oxygen yields carbon dioxide plus water. Here we have a reaction with much bigger subscripts than we've seen before, 26 hydrogen atoms in the reactants. Will this be harder to balance than the simple reactions we've looked at so far? We might want to approach this like some of the problems we've seen before and work systematically to balance each element in the equation. Let's start by balancing the carbon atoms. We have 12 on the left side, so we add a coefficient of 12 on the right side to the carbon dioxide molecule. We might also observe that we have 26 hydrogen atoms in dodecane, and we can balance the hydrogen atoms by adding a coefficient of 13 to the water molecule to create 13 times 2 equals 26 hydrogen atoms on the product side of the equation. Can we easily balance the oxygens? We have 24 plus 13 oxygen atoms on the right side, which adds to 37, an odd number. But we have 2 oxygens on the left side. How do we make that an odd number? It looks like we will have to scrap our work so far and start over. You're actually not that far away from solving it, but it's so easy to get discouraged when working with larger numbers. Perhaps we could find a pattern from some of the other hydrocarbon combustion equations. Let's look at the balanced reactions of some simpler hydrocarbons, specifically at the coefficients. In the combustion of methane, 1 molecule of methane plus 1 molecule of oxygen yields 1 molecule of carbon dioxide plus 2 molecules of water. The coefficients of the balance equations are 1, 1, 1, 2. For ethane, the coefficients are 2, 7, 4, 6. It's hard to see a pattern emerging with only 2 examples. Let's try one more reaction. This is discouraging. Propane's coefficients are 1, 5, 3, 4. Some have gone up and some have gone down. Dodecane has an even number of carbon atoms, so it might also have a coefficient of 2. But how many reactions do we have to balance to be sure of a pattern? We're new to this, but we have had a lot of practice with algebra. Let A, B, C, and D represent the number of molecules of dodecane, oxygen, carbon dioxide, and water in a balanced equation. A dodecane plus B oxygen yields C carbon dioxide plus D water. Now we create equations for each of the elements and put an equal sign between reactants and products. A times the 12 carbon atoms in dodecane equals the C carbon atoms in carbon dioxide. Likewise, A times the 26 hydrogen atoms in dodecane equals D times the 2 hydrogen atoms in water. And finally, B times the 2 oxygen atoms on the left side equals C times the 2 oxygen atoms in carbon dioxide plus D times the oxygen atoms in water. Oxygen is in both molecules on the right side of the equation. Let's look at the carbon equation first. We can give A or C any value. Let's make one of them the number 1. That's an easy number. However, if C is 1, then A would be 1 over 12. We want to avoid fractions, so this is not a good start. But if A equals 1, then C equals 12. Furthermore, D is 13, as in the hydrogen equation, 26 times 1 equals 2 times D. D equals 26 divided by 2, D equals 13. We solve for B in the oxygen equation as shown. 2 times B equals 2 times 12 plus 13. 2B equals 37. B equals 37 divided by 2, or 18.5. Is this an acceptable solution? Let's look at our reaction again with these coefficients that we know work, but might not be what we want. We have 1 molecule of dodecane plus 18.5 molecules of oxygen yields 12 molecules of carbon dioxide plus 13 molecules of water. We want positive integers in our solution as the coefficients. Our only problem is the 18.5 oxygen molecules. If we multiply the entire equation by 2, we will get 2 molecules of dodecane plus 37 molecules of oxygen yields 24 molecules of carbon dioxide plus 26 molecules of water. Counting the number of atoms for each element on each side of the reaction shows they are indeed equal. We have balanced the combustion reaction of dodecane as required. As we continue to work on balancing reactions, you may get a feel for doing it systematically. If not, algebra is a reliable fallback using tools you already have in your belt.